Welcome to another installment of the Robinson Twins Present. This installment, though, doesn't really fit any of our other playlists, but this is about a mathematical game that I learned in 8th grade. And it was first described by a French mathematician, Edouard Lucas, in 1883, and is believed to have come from Southeast Asia. So it goes by the name the Towers of Hanoi. It's also called Lucas's Tower. But I learned about it in 8th grade, and our 8th grade teacher gave me a chance to earn some extra credit by doing some calculations involving this simple game which has numbers that build up exponentially. And it was a time-consuming project, but I earned some extra credit, and I'll describe that to you in this installment. So let's take a look. The game consists of a board with 3 pegs that can be in a straight line or triangular, and a varying number of discs forming a stack, and the goal is to move the stack of discs from one peg to another, but you can only move one disc at a time. Each move consists of taking the upper disc from one of the existing stacks and moving it to another peg, and you can never place larger discs on top of smaller ones. Simple rules, and yet the number of moves will increase exponentially, like this. The minimum number of moves it will take to complete the game can be summed up in this formula, with n as the number of discs, 2 to the nth power minus 1. So 2 raised to the power of the number of discs and subtract 1. And the game can be varied based on how many discs you place in the stack. So as an example, the game pictured here has a total of 8 discs. So 2 raised to the 8th power is 256. 256 minus 1 is 255. That's the minimum number of moves it would take to completely move the entire stack from one peg to another. If we start with only one disc, 2 to the first power is 2 minus 1 is 1. Well, that makes sense. This is going to take just one move and we're done. So let's add another disc. 2 to the second power is 4, minus 1 is 3. This will take 3 moves. So we go 1, 2, and 3, and we've moved the stack from one peg to another. One disc at a time, without putting a larger one on top of a smaller one. Alright, let's go one step more, put a third disc on. 2 to the third power is 8, minus 1 is 7. So this will take 7 moves. Here's 1, 2, 3, 4, 5, 6, and 7 moves, exactly as predicted. When I did research for this game on Wikipedia, I found this picture from a museum in Mexico, and that Lucas Tower in the corner has 32 discs. So 32 discs, 2 to the 32nd power, and that's a big number. That number is 4,294,967,295 moves after you subtract 1. And that would take more time than you actually have in a lifetime. And here's how that works out. There are 31,557,600 seconds in a year. So dividing that into the number of moves this would take to complete, you would take 136.1 years to complete this one game, if you could move the discs 1 per second. So my 8th grade teacher gave as an extra credit assignment this game. If it had 100 discs, how many moves would that take? So this was, we were just getting calculators in school at the time, and there were no calculators that had enough digits anyway. So I ended up doing the entire project on paper, for several hours. It was for extra credit and nobody else wanted to do it, and I thought, I can do it. So I did. And I came back the next day and put the number on the board. I started off by employing a strategy where I took 2 to the 100th power and realized that every pairs of 2's would multiply together to get 4, so then that would make it 4 to the 50th power. And then every pair of 4's would make 16, so that would make it 16 to the 25th power. And then from there, I went one more step. 16 times 16 is 256. So I'd have 256 to the 12th power with another 16 left over. So that's how I started the work on paper. So I figured that computers today would allow me to just put in 2 to the 100th power and it would spit out the answer in less than a second and I'd have the full answer. But it turns out the spreadsheet I used, Google Sheets, I tried in another spreadsheet and they rounded off. So I thought, how do I get the right number? All the way to the ones place, the number that I got when I did it on paper. So I finally found a website that does it. It was called Wolfram Alpha. They're not a sponsor, and I'm not trying to push them, but onto people. But they actually delivered the answer. So take a look at this. Okay, so here's the website I found that I can use to calculate the 2 to the 100th power and actually get the numbers all the way to the ones place. So here, I'm not advertising them. They're not sponsoring me. Just so you know, I was searching online for something that would do the math, and this is all that came up, and it works. So I can type in 2, the correct symbol to go raised to the power of 100, and when I hit enter, comes up and it gives me the answer there all the way to the ones place. 1 nonillion, 267 octillion, 650 septillion, 600 sextillion, 228 quintillion, 229 quadrillion, 401 trillion, 496 billion, 703 million, 205,376. And then to get the answer to how many moves it would take, I subtract 1, so that ends up at the end here as 375. So that's the complete answer. And the spreadsheets actually wouldn't provide that. It rounded off at the quadrillions place, so it was 230 and then the rest zeros. So this is a challenging number even for today's machines, I guess. So here's 2 to the 100th power written out on the left side, and then subtracting 1 to get the number of moves on the right side. To give you an idea how big a number this is for doing 100 disks, scientists estimate the universe since the Big Bang has passed with 14 billion years. If you had started this game with 100 disks at the start of the Big Bang and continued moving disks for every second since then, in 14 billion years, you would still not be finished with the game. It's a big number. Now to wrap things up, I just show the game that I bought online to demonstrate for this video. This one has 10 disks, so 2 to the 10th power is 1024 minus 1 is 1023. So that's how many moves this game would take for me to complete it. I don't think I'm going to add any more than 10. Hope you enjoyed this type of content. Please sure to like and subscribe. Hit the notification bell, and hope to see you in the next Robinson Twins Present video.